Good morning, everyone. Welcome to the next lecture. Today we will introduce another method for solving the system of linear equation that use determinant, which is generally known as it is Cramer's rule. And the Cramer's rule is a viable, simplified, and efficient method for finding a solution to the system of linear equation through use of determinant, provided that we have a same number of equation as unknown variable we have. So today we will discuss the Cramer's rule in details. The Cramer's rule is actually named after its innovator, that is the Swiss mathematician, the Gabriel Cramer. And the Cramer rule is actually provide a formula for finding the value of unknown variables given in the linear equation without explicitly solving the entire system. And the rule states that if the determinant of a coefficient matrix of the system of linear equation is non-zero, which means that if it is a non-singular matrix, then the system has a unique solution. When the number of equation is equal to the number of unknowns and the determinant of a coefficient has non-zero value, then the system has a unique solution, which we can find by using the Cramer's formula, that is xi is equal to the determinant of ai divided by the determinant of a, where xi is the ith unknown variable in the equation, and here ai, determinant ai, which is nothing but it is the determinant of a special matrix which is formed from the original matrix. Then the determinant of a, which is showing that the determinant of a given matrix or original matrix. So this Cramer's rule is actually provide one of the simplest way to find, or it is simplest procedure or method for solving the system of linear equation through use of determinant. Now let us consider one example. We have an equation that is 7x plus 2y is equal to 60. Similarly, we have the another one that is x plus 8y is equal to 78. We have a linear equation with the two unknown variables we have here, that is x and y. We want to find out the value of x and y by using the Cramer's rule. See here, we can write this particular linear equation, system of linear equation in the form of ax is equal to b. So here a is the coefficient matrix, x is the variable matrix, and b is the constant matrix. So here the a matrix or a coefficients are here 7, 2, 1, 8. That is the coefficient of variables. So I am writing here the a is equal to 7, 2, 1, 8. Then the variable matrix, that is x, see here we have a two variables are, that is x and y, which is equal to b, which is the constant matrix, that is 60 and 78. Now after writing in the form of ax is equal to b, the next step is to find the determinant value of original matrix. So here the determinant of a, that is 7, 2, 1, 8, which is equal to 7 into 8 minus 2 into 1. So I am writing here 7 into 8, which is equal to 56, minus 2 into 1, which is equal to 2. So 56 minus 2, which is 54. So the determinant value of the original matrix is 54. Now I am going to form a new matrix. See here, by replacing the first column. By replacing the first column in the original matrix by using the constant matrix. See here, the constant matrix is 60, 78. So I am going to write this 60 and 78 instead of the first elements or first column elements here. So instead of 7 and 1, now I am going to write 60 and 78 here. So the first column will become 60 and 78 and the second column will be as like, that is 2 and 8. Now this is we are terming as the matrix A1. So this is a special matrix which we are actually formed by replacing the first column of the original matrix by using the constant matrix. So now we are going to find the determinant value of the special matrix A1. So here of course it is 60 into 8 minus 2 into 78. So 60 into 8 which is equal to 480 minus 2 into 78 which is equal to 156. So if you go for solving it, then it is equal to 324. So the determinant value of the special matrix A1 which is equal to 324. Now the similar way we are also going to form another special matrix that is known as A2 by replacing the second column by using the constant matrix. So here the first column will be the similar, that is 7 and 1, and the second column will be replaced, that is 2 and 8 will be replaced with 60 and 78. So it will become 7, 1, 60 and 78. Now after finding or forming this particular special matrix, that is A2, we are going to find the determinant value here. So here the determinant value A2 which is equal to 7, 60, 1, 78. So we are going to multiply 7 into 78, then 6 into 60 into 1. So it will become 7 into 78 which is equal to 546 minus 60 into 1 which is equal to 60. Now we are going to form the second special matrix which I am denoting here. It is A2, where I am going to replace the second column by using the constant matrix. The first column will be the similar, that is 7 and 1, and the second column, that is 2 and 8, now I am going to replace with the constant matrix, that is 60 and 78. So here the second column will be the 60 and 78, the first column will be the earlier one, that is 7 and 1. Now we are going to find the determinant value of this special matrix, that is determinant of A2 which is equal to 760, 178. We are going to multiply 7 into 78 minus 60 into 1. So 7 into 78 which is equal to 546 minus 60 into 1 which is equal to 60. So 546 minus 60 which is equal to 486. So this is the determinant value of the second special matrix, that is A2. Now after getting the determinant values, see the next step we want to find out, or we want to find out the value for unknown variable x and y. See here x is equal to, that is the determinant value of A1 divided by determinant value of A. Similarly, the y is equal to the determinant value of A2 divided by determinant value of A. So here the determinant value of A1, that is equal to, here it is 324 divided by the determinant value which is equal to 54. So 324 divided by 54 which is equal to 6. So the value of x is equal to 6, and similarly the value of y is equal to, see the determinant value of A2 divided by A. So here the determinant value of A2, that is 486 divided by the determinant value of A which is equal to 54. So 486 divided by 54 which is equal to 9. So the value of x is equal to 6 and the value of y is equal to 9. Now consider another example. We have given simultaneous equation with the two unknown variables, that is 18p1 minus p2 which is equal to 87 minus 2p1 plus 36p2 which is equal to 98. So we have a system of linear equation here. The variables here are p1 and p2, and we are going to form, or we are going to rewrite this particular system of linear equation in the form of Ax is equal to b. So here the A, that is coefficient matrix, so coefficient are here 18, minus 1, minus 2 and 36. So into the P, that is P1, P2, this is the variable matrix. P1 and P2 are the variable matrix which is equal to 87 and 98. This is the constant matrix. Now after finding Ax is equal to B format, now we are going to frame the matrix A, that is coefficient matrix 18, minus 1, minus 2 and 36, where we are going to find the determinant value. So the determinant value of this original matrix, that is 18 into 36 minus 1 into minus 2. So 18 into 36 which is equal to 648 minus 1 into minus 2 which is equal to 2. So it is 648 minus 2 which is equal to 646. So the determinant value of the original matrix A, which is 646. Now I am going to frame a new matrix by replacing the first column, that is 18 and minus 2, with 87 and 98, that is constant matrix. So here I am writing the new special matrix, that is A1, which is equal to, see, the first column will be the constant matrix that is 87 and 98. Then the second column will be as it is, that is minus 136. This is the special matrix which is named as A1. Now we are going to find the determinant value of the special matrix A1. So which is equal to 87 minus 1, 98, 36. See, if you go for finding the determinant value of the special matrix here, that is A1, then we can multiply 87 into 36 minus 1 into 98. So it will be, see, 87 into 36, which is 3132, minus 1 into 98, which is equal to minus 98. So here we have minus and minus sign, so it will become plus. So 3132 plus 98, which is equal to 3230. So it is the determinant value of the special matrix, that is A1. This is A1, determinant value of A1. So now we are going to frame the second matrix, special matrix, that is A2, by replacing the second column, that is minus 136, by using the constant matrix, that is 87 and 98. So here I am framing the new matrix, special matrix, that is A2. So the first column will be as it is, that is 18 minus 2 into the second column, that is minus 136, will be replaced with 87 and 98. So after framing this special matrix A2, we are going to find the determinant value. So here the determinant value of A2 is equal to 18 into 98 minus 87 into minus 2. So 18 into 98, which is equal to 1764, minus 87 into minus 2, which is equal to minus 174. So we have a minus and minus here, so it will become plus. So if you go for adding these two terms, then it will become 1938. So now we are going to find the value of P1 and P2. So here the P1 is equal to, that is determinant value of the special matrix 1 divided by the determinant of A, which is equal to, see here the determinant of special matrix A1, which is equal to 3230, divided by the determinant of A, that is 646. So 3230 divided by 646, which is equal to 5. Similarly, P2 is equal to, that is determinant of special matrix 2 divided by the original determinant of A. So here it will become 1938 divided by 646, which is equal to 3. So here P1 is equal to 5 and P2 is equal to 3. In this way, we can find the value of the unknown variables in the given system of linear equation. Now let us consider, we have an application level question by giving an ISLM model. See here, we have given IS equation, that is 0.3y plus 100i, which is equal to 252. And the LM equation, which is equal to 0.25y minus 200i, which is equal to 176. See, this example we are already solved by using the method of inverse of matrix. So here again we are going to solve this particular method, this particular problem by using the Cramer's rule. So here we have a system of linear equation and we want to find out the equilibrium level of income and the rate of interest. So here the IS equation, that is 0.3y plus 100i, which is equal to 252, and the LM equation we have 0.25y minus 200i, which is equal to 176. So we have a system of linear equation. We are going to write this particular equation in the form of Ax is equal to b. So here A is the coefficient of the variable. Here the variable are y and I. So here we can rewrite in the form of Ax is equal to b. Then it is 0.3, 100, 0.25 minus 200. Then variable matrix here it is y and I, which is equal to 252 and 176. See, after forming in this particular format, that is Ax is equal to b, then the next step we want to find out the determinant value of the original matrix, that is matrix A. So here the determinant value of A, we can multiply 0.3 into minus 200 minus 100 into 0.25. So if you go for multiplying 0.3 into 200 minus 200, then it will become minus 60, then minus 100 into 0.25, which is equal to 25. So it is minus 60 minus 25, which is equal to minus 85. So this is the determinant value, that is minus 85. Now we are going to replace the first column of the original matrix by using the constant matrix elements, that is 252, 176 instead of 0.3 and 0.25. And so that we will get a special matrix. So here the special matrix, that is A1, which is equal to, now I am writing the first column as 252, 176 instead of 0.3 and 0.25. And the second column will be as it is, that is 100 and minus 200. So after that, we are going to find the determinant value of the special matrix, that is A1, so which is equal to 252 into minus 200 and 100 into 176. So if you go for multiplying these two values, that is 252 into minus 200, then it will become 50,400 minus 50,400 minus 100 into 176, that is 17,600. If you go for subtracting these two elements, then it will become, see, it is minus 68,000. It is minus 68,000. So the determinant value here is, it is minus 68,000. Now after that, we are again going to frame this special matrix, that is A2. So here A2 we are framing by replacing the second column by using the constant matrix. So here the second column elements are 100 minus 200. We are going to replace with the 252 and 176. So now we are going to find the determinant value of A2, which is equal to 0.3, 252, 0.25, 176. So here we are going to multiply 0.3 into 176, which is equal to 52.8 minus 252 into 0.25, which is equal to 63. So if you take the difference between these two numbers, then it will become minus 10.2. It is minus 10.2. That is determinant value of A2 is equal to minus 10.2. Now we can find the value of y and I. See here, y is equal to the determinant value of 1 divided by the original determinant value, which is equal to minus 68,000 divided by minus 85, which is equal to 800. Similarly, the interest rate, that is I, is equal to the determinant value of A2 divided by the determinant value of A, which is equal to minus 10.2 divided by minus 85, which is equal to 0.12. So the equilibrium level of income here, it is 800, and the rate of interest is equal to 0.12. So this is the equilibrium level of income, and the equilibrium level of rate of interest is equal to 0.12. Now we are going to use the Cramer's rule for solving the unknowns of the following equation. We have the system of linear equation, but here instead of 2 by 2 order, we will have a 3 by 3 order, because we have a 3 linear equation with the 3 unknown variables are here. See, what are the unknown variables here? It is x, y and z. So now we are going to rewrite this particular equation in the form of ax is equal to b. Then here it is, see, a is equal to, it is the coefficient of the variables, that is 2, 4, minus 1, 1, minus 3, 2, 6, 5 and 1. And we have the variable matrix, that is x, y and z. And here the constant matrix are 15, minus 5 and 28. So the first step, we are going to find the determinant value of the given matrix A. So it is, see, we are going to take the first element, that is 2, and then we are going to cross the first row and the first column. Then it will become, see, 2 into minus 3 into 1 minus 2 into 5. Then minus the second element, that is 4 into, then crossing the second column and the first row, that is 1 into 1 minus 2 into 6. Then we have minus 1 here, so we are putting here it is minus 1 into, crossing the first row and the third column, then it will become 1 into 5 minus 3 into 6. So if you go for simplifying it, then it is minus 2 into minus 3 into 1, which is equal to minus 3, minus 2 into 5, which is equal to 10, minus 4 into 1 into 1, which is equal to 1, minus 2 into 6, which is minus 12. Minus 1 into 5, which is equal to 5 plus minus. Here we have 2 minus, so it will become plus 18. So here if you go for simplifying again, then 2 into minus 3 minus 10, which is minus 13, minus 4 into 1 minus 12, which is equal to minus 11, then minus 1 into 5 plus 18, which is equal to 23. If you go for simplifying it, then it is minus 26 plus 44 minus 23, which is equal to minus 5. So the determinant value of here given matrix is equal to minus 5. Now we are going to replace the first column of the original matrix A by using the constant matrix, that is 15, minus 5 and 28 instead of 2, 1 and 6, so that we will get a special matrix. So this special matrix is formed here. See, by replacing the first column by using the constant matrix, that is 15, minus 5, 28. The second column and the third column will be as it is. So now the special matrix, that is A1, we are going to find the determinant value of the special matrix A1. So it will be, see, it is the first element, that is 15 into crossing the concerned row and column, then it is minus 3 into 1, minus 2 into 5. Then minus 4 into concerned row and column will be cancelled out, then minus 1 into 5, minus 2 into 28. Minus 1 into, then first row and the third column will be cancelled out, then minus 5 into 5, minus 3 into 28. So if you go for simplifying it, then it is 15 into 3, minus 3 into 1, which is equal to minus 3, minus 2 into 5, which is equal to 10, minus 4 into minus 5 into 1, which is equal to minus 5, then 2 into 28, which is equal to 56, minus 1 into 5 into 5, which is equal to minus 25, then here minus 3 into 28, which is equal to 84, minus will be plus, so it will be plus 84. So it is 15 into minus 13, minus 4 into minus 61, minus 1 into, it is plus 59. So if you go for simplifying it, then determinant value of the special matrix A1, which is equal to minus 10. Now again we are going to form a special new matrix, that is A2, by replacing the second column, that is 4, minus 3 and 5 by 15, minus 5 and 28. So here the second column will be 15, minus 5, 28. And the first column and the third column will be as it is. So this is termed as A2. So we are going to find the determinant value of A2 again. So the determinant value of A2 is equal to, see here, it is 2 into minus 5 into 1, minus 2 into 28, then minus 15 into crossing the second row and the second column and the first row, that is 1 into 1, minus 2 into 6, minus 1 into, then 1 into 28, minus 5 into 6. So here it will be, see, 2 into minus 1, minus 56, then minus 15 here, 1 into 1, 1 minus 2 into 6, which is 12, minus 1 into 28, which is equal to 28, then 5 into 6, which is equal to 30, so minus will become plus, so it is plus 30 here. So it is 2 into minus 5 minus 56, which is equal to minus 61, then minus 15, 1 minus 12, which is equal to minus 11, then minus 1 into 28 plus 30, which is equal to 58. So if you go for multiplying this term and simplify it, then it is minus 122 plus 165 minus 58, which is equal to minus 15. So now again we are going to frame another special matrix, which is termed as A3, by replacing the third column by using the constant matrix. The first and the second column will be as it is. The third column will be, see here, it is 15, minus 5 and 28. Now we are going to find the determinant value of the special matrix, that is A3. Then if you go for finding the determinant value, then it is equal to 2 into, then minus 3 into 28, minus 5 into 5. Then minus 4 into 1 into 28, minus 5 into 6. Plus 15 into, then we have 1 into 5, minus 3 into 6. So here 2 into minus 3 into 28, which is equal to minus 84. here minus minus it will become plus 5 into 5 which is equal to 25, minus 4 into 28, minus minus will become plus 5 into 6 which is equal to 30, plus 15 into 1 into 5 which is equal to 5, plus 3 into 6 which is equal to 18. So here if you go for adding these terms, then it will become 2 into minus 59 into minus 4 into 28 plus 30 which is equal to 58 plus 15 into 5 plus 18 which is equal to 23. So if you multiply these terms, then it will become minus 118 minus 232 plus 345 which is equal to minus 5. So now we can find the value of x and y, z. See here, the determinant value of original matrix was minus 5. The determinant value of special matrix A1 which is equal to minus 10. The determinant of A2 that is minus 15 and determinant of A3 which is equal to minus 5. So here the value of x, y and z which is equal to x is equal to A1 divided by A, that is determinant of A1 divided by determinant of A which is equal to minus 10 divided by minus 5 which is equal to 2. Y is equal to determinant of A2 divided by determinant of A which is minus 15 divided by minus 5 which is equal to 3. Then Z is equal to A3 divided by A, that is minus 5 divided by minus 5 which is equal to 1. So here x is equal to 2, y is equal to 3 and z is equal to 1. So in this way you can solve the system of linear equation by using Cramer's rule. Now consider the one more example. We have a system of linear equation with the 3 unknown variables. Similar to the previous example, we have a x, y, z variable. We are going to frame Ax is equal to b. Here A is equal to the coefficient matrix, we have a variable matrix and we have a constant matrix. So now we are going to find the determinant value of the original matrix, that is A. If you go for finding the determinant value here, then it will become, see, first element into crossing the concerned row and column, 3 into 6 minus minus 5 into 5 minus minus 2 into 2 into 6 minus minus 5 into 4 plus 3 into 2 into minus 5 minus 3 into 4. If you go for simplifying it, then it is the determinant value will be equal to minus 37. The determinant value is here, it is minus 37. Now we are going to frame a new matrix that is termed as A1 by replacing the first column by using the constant matrix, that is 16, 2, 7. So here 16, 2, 7 and the second and third column will be as it is. So here we are going to find the determinant value of A1. So if you go for finding the determinant value, see, I am just showing here the final result, that is determinant value of A1 is equal to minus 111. Similarly, now I am going to find the A2 by replacing the second column by using the constant matrix, that is 16, 2, 7, by replacing minus 2, 3 and minus 5. So we have a new matrix, that is A2 here, and this we are going to find out the determinant value of the special matrix, that is A2. So here if you go for finding the determinant value, you know how to solve or how to find the determinant value. I am not going to repeat it again here. So it will be equal to, see, the determinant value A2 is equal to, it is minus 259. Similarly, again I am going to frame the third special matrix, that is A3, by replacing the third column, that is 3, minus 5 and 6, by using the constant matrix, that is 16, 2 and 7. So here the third column is replaced. The first column and the second column will be as it is. So the A3 here we are given and we are going to find the determinant value. Of course, you know it how to find the determinant value. I am not going to repeat it again. So here the determinant value of A3 is equal to minus 185. So we found the determinant of A, determinant of A1, determinant of A2 and determinant of A3. So I am just writing down here all the values. See here minus 37, that is determinant A. Determinant A1 which is equal to minus 111, determinant A2 which is equal to minus 259 and determinant A3 which is equal to minus 185. So I can solve here, that is x is equal to the determinant a1 divided by a, which is minus 111 divided by minus 37, which is equal to 3. Similarly, a2 divided by a, so it is minus 259 divided by minus 37. If you go for simplifying it, then it is 7. Then z is equal to determinant a3 divided by a, which is equal to minus 185 divided by minus 37, which is equal to 5. So here the value of x is equal to 3, the value of y is equal to 7, and the value of z is equal to 5. So this method is actually showing that how to solve the system of linear equation by using the Cramer's rule. So earlier we are also solved the system of linear equation by using the inverse of matrix method. But as compared to the inverse of matrix method, I think that the Cramer's rule is very easy as compared to the earlier one. So let me conclude here. Today we have discussed the Cramer's rule for solving the system of linear equation that use the determinant for finding the solutions of the unknown variables given in the system of linear equation. So I hope it was clear to you, and we will see in the next lecture. Thank you.